Day 7, we are going to be doing surface area and volume now for combined objects. So it's problem solving, for sure it's problem solving. And they're using this word here, composite. It just means combined. It's just when they put objects together. That's all it is. They're just going to smush objects together. Alright, this first one, we're going to take care of surface area. These are by far the harder ones. The volume is much easier. Surface area is much more challenging. So for surface area, you are looking for exposed surfaces only. It's the stuff you can see on the outside. Okay? What is a surface? A surface is a face. You're looking for the faces on the outside. That's what you're looking for. Let's take a look at this first object. The object on top is half of a cylinder. So you're going to find the surface area for the half cylinder. What do you suppose you're going to do? Yeah, that's perfect. Do it normally and then divide it by 2. Alright, the formula for the cylinder is 2 pi r squared plus 2 pi r h. She said just do it and then get the answer and divide it by 2. You can definitely do that. So getting the answer would be the thing in the brackets and then divide by 2. You could mess with this algebraically though. You could do this, divide 2, but you don't have to go that route. You don't have to go that route. You could, but let's just find out the answer and then divide it by 2. Alright, so we have 2 pi. The radius of that cylinder would be? Good. Very nice. 2 pi, the radius would be 3, and the height of that cylinder is? Very nice. I heard 8 a couple times. That's excellent. Let's get that answer, and then once we get that answer, we will, of course, divide by 2. So get the answer first. That's in the brackets. Do the brackets first. Get the answer, divide by 2. And we're using the pi button. I got 103.67. You guys agree? Do you guys agree? Alright, so that's for the half cylinder. We've taken care of the top object. Now we need to take care of the bottom object, which is a prism. So when you go look at your formula sheet, you have a formula for this. However, you have to modify it because there's one surface that's not exposed. It's this top surface that's actually not even there. That top surface is not even there. If you were to walk in that building, maybe it's a shed for really, really little people, you walk in there, there's just empty space. That face is not there. So you do not need to calculate that surface. So what I would do is I would just do all these faces for the bottom shape individually. Let's take care of the front and the back. Face 1 and face 2. What's the dimensions of face 1 and face 2? 6 by 3. Okay, 6 by 3. That's area of a rectangle. And it's 6 by 3. And you get 18 square centimeters. And what should I do with that 18? That's only one of the faces, right? So what could you do to that number? Double it up. Why would I double it up? Good. There's two of them. Okay. Any questions about that? We're just trying to break this problem into simpler steps. Okay, let's do the sides. Side 3 and side 4. On the side here, what are the dimensions of these rectangles? 8 by 3. Excellent. So if that was area 1, let's call this area 2. Length times width, 8 by 3. That's 24 square centimeters. And I should, of course, do what with that value? Double it up. Why would I double it up? Because there's 2 of them. All right. Do I need to do the bottom? Yeah. If you were to hold the object up in the air and look underneath, that surface would be there. So we need to do the bottom surface. What is the dimensions of the bottom surface? 6 by 8. Let's call that area 3. 6 by 8 is 48. Now in green, surface area total, I just have to sum all these faces, all these calculations. I got this one, I got this one, and this one. Those 4? Is that all? I think so. Altogether, 235.67 square centimeters. How we feel about that? Decent? I mean, it's not overly taxing on the brain if you break the larger problem into smaller parts. That is my recommendation for surface area of component figures. The hardest part about this is not just blindly following these formulas. Some of them, yeah, you do, especially like the sphere and the cylinder. But like the prisms, the pyramids, sometimes you have to be just clever and just do the two-dimensional stuff one at a time. Remember, the two-dimensional stuff is all on the front page at the bottom. So squares, rectangles, circles, and triangles. Don't forget this spot here on the data sheet. Yeah, I feel you, man. I feel you. All right, take a deep breath, like me and Espoir, and we'll get going into the next one. Oh! Okay, when I'm done teaching, we'll talk about it. Okay? All right, let's take a look at this. Let's start with the top figure. What is the name of the top figure? Beautiful. Triangular prism, because the two triangle faces are parallel. If you look at your data sheet, lo and behold, it's not there. Triangular prism is not there. Again, surface area is a sum of all two-dimensional faces, sum of 2D faces. On the surface, of course. On the surface. So those triangles, just do them like you're back in junior high, maybe grade 7 or maybe even grade 6. Area of a triangle. It's not too shabby. Area is base times height divided by 2. We are talking about this triangle, of course. What is the length of the base? 2.5. The height, is this vertical height. Remember, those heights are always perpendicular to the base. It is a length of 1. And then we have to divide by 2. 2.5 times 1 divided by 2. That is 1.25 square meters. And what should I do with that value? Multiply it by 2 because there are 2 of them. Very nice. That gives me a value of 2.5 square meters. Do you guys agree? All right. Let's do the roof on the right. I'm talking about this one here. What's the dimensions of that roof? I know this one. What's that? 3. What's this one? Uh-oh. Pythagorean theorem, I love it. This triangle is right-angled. One of the lengths is 1. What's this length right there? Half of 2.5. The reason it's half is because when you drop a perpendicular bisector, it cuts it in half. If you drop a perpendicular, it should cut that in half. Half of 2.5 is 1.25. Everybody comfortable with that? So I guess, in general, if you're missing a dimension, look for Pythagoras. There's really nothing else to it. Okay? That's pretty much the only hiccup you might see. We're solving for the long side. So we want C. Long side you will of course add. We got a 1 square and a 1.25 square. Yeah, pretty much 1.6 roughly. All right. Area 2, the green rectangle, is a length by a width. 1.6 times 3. 1.6 times 3 is 4.8. What should I do with that 4.8? Multiply it by 2 because there are, of course, 2 of them. Why didn't I multiply by 3 or something? Do we count the thing underneath? Good. Whoa. This 4.8 times 2, 9.6. Any questions so far? All right. Just like on the last picture, I am omitting like this top of the prism, the top of the box. I'm omitting that. Okay? Because it's not on the surface. It's not exposed, so we don't care about it. So when you go to do the bottom part of the shape, it's very similar to the last. Let's do the front. 2.5 by 2. I'm going to go quicker now because we pretty much did this on the last example. 2.5 by 2 is 5 square meters. We're going to times that by 2 because there's a front and a back. That's 10 square meters. Jump to the side. That's 2 by 3. So 6 square meters. Timesing it by 2, you get 12 square meters. And now for the bottom, underneath, that's 2.5 times 3. This is 7.5. I'm not going to times by anything because I'm omitting the top. Surface area is the sum total. We need to add up all these values. 2.5, 9.6, and those 3. I got a sum total of 41.6. Square meter. So a lot of work, but I don't think it's overly taxing on the logic centers in your brain. Surface area will be more challenging than volume. You have to visualize which surfaces are exposed. Any questions before we go to the next page, volume? Beautiful. This lesson is much shorter than what we've had in the past, so you will have lots of time to practice. Lots of time to practice. The next one, we are calculating volume. So to find the volume, it's just going to be V1 plus V2 if this shape has volume V1 and this shape has volume V2. You just have to add those up. So let's go ahead and find V1. What shape is V1? Cone. 1/3 pi r squared h. Just from my data sheet. One-third pi. The radius, of course, is good. And the height is 4. Very nice. That 1/3, you can put it in your calculator to start off if you have a nicer one. You can just go like this. 1 divide 3, and then the pi button. If you don't have that nice calculator, just get pi r squared h and then divide it by 3 at the end. I got 37.7. This is volume, so cubic inch.
Leon Thompson, can you phone 249 Leon 249, please?
Now V2 is which shape? Hemisphere, which can be found directly on your pink sheet. Two-thirds pi r cubed way at the bottom. The radius. What is the radius of this hemisphere? 3. It's the radius of the sphere, 3, which is the same value you're going to use in the calculation. So if you don't have a nice calculator, you got an old one, just go 3 cubed times pi times 2 and then divide it by 3. If you got a new one, a nice one, you can just type it in as you see it. And 3 cubed, I got 56.5. I highly recommend that you're typing these in as you go just in case you don't get the same answer and maybe you don't know how to use your calculator properly. All right, taking these two values for V1 and V2 and adding them up, I get V total 94.2 cubic inch. This one's not brain surgery or anything like this. So hopefully this is okay. You very well could see something like this in the written response on your test. Very easy to prepare for, not overly daunting. Like I said before, a lot of people have actually scored 100 on the very first exam. Now this one's a little bit more dicey. In fact, it's a lot more dicey. They give you a shape of what looks like a home, or a shed or something like this, or a garage, I don't know, small garage. Maybe you could fit one car in there. 10 meters? Oh, you could fit more than that. I was thinking feet. So it's quite a big space, and oh, it's a home. It tells you this. This is a home. Now it tells you cost as a rate. This is a rate. A rate is a comparison of two units. In this case, it's dollars per meter cube. Dollar per meter cube. If there was only 1 meter cube, it would cost $1.95. If there was 2 meter cubes, you take that $1.95 and times it by 2. So all you need to do is find out how much cubic meters there are. So you need to find volume. You have two shapes. The bottom shape, zero worries about that bottom shape. That bottom shape is a prism, LWH. This is a dream how easy this one is. So I'll just have you guys finish this calculation and then we will pause for these two presenters. Math 10C. Alright, so throw your math on pause and please listen up. You guys ever watch Star Trek? Engage. Alright, here we go. Now, let's take a look at volume 2, and then we'll get this finished with, and then you'll have about 15 minutes for homework. All right, let's take a look. People, we already did the bottom prism, so let's talk about the top shape. What is the top shape? Good, pyramid, and thank you for using the word square. This is a 10 by 10. If you go and look for the volume of a pyramid, you see that it's 1/3 LWH. In this case, L and W are the same, okay? So L and W are the same. You can just use x squared if you like. What are we missing, though? Good people, what are we missing? Very nice. The height. So it is easy, someone said. What could you do? Very nice, sir. Take away the 2.32, this height of the prism, from this given height from the bottom to the top. Because I have to see it. Just because I know math doesn't mean I know arithmetic. What am I doing? You got me rattled. Okay, there it is. This is the height. Okay, so when you go to do volume 2, 1/3, whoops, 1/3 LWH, you have 10 by 10 by 2.04. And you get 68 cubic meters. Is everybody okay with that? All right. What are we going to do with these two values? Add them up. 232 plus 68. I got 300 meters cubed total. You guys okay over there? Do you have a question? Let me just finish this off and then you can go. You guys okay? Rochelle? All right, so thank you. Now, this 300 meters cube, watch what I do now. Multiply it by the rate, $1.95 per meter cube. What happens to those units? And left in which unit? You're just left in dollars. Okay, so $1.95 times 300. Thank you for your patience. Your assignment is right here. Okay, please work diligently and quietly.